Welcome, ladies and gentlemen, to part 2 of this Kuta worksheet tutorial. This time we're taking on sector area. In part 1, we talked about arc length. So let's go ahead and get started with number 13. But before we do, I like to give an example on how to determine sector area. I like to think about it in a more simplistic way before getting into the more complex. Let's say we have a circle, and in this circle, we have half of it shaded in, and we want to find the area of half that circle. How would we calculate it? Well, as we know, the area of a circle is pi r squared. We multiply r times r, and we multiply that by pi, and that is the area of the complete circle. Now, if we're looking for just half of that circle, what would we do? Well, we would take that area. Okay, I'm going to use blue. A equals pi r squared, and we just simply multiply it by 1/2. Now, let's say, for argument's sake, that we're going to take half this, but we're going to say that's only 180 degrees. It's the equivalent. 180 degrees is half a circle. How do we know? Well, let's take 180. We divide it by 360. This is akin to what we did with the arc length in the first example. Same deal. We saw that 180 divided by 360, 1/2. Here, 180 divided by 360, 1/2. So you can see that we can find the portion of the circle by taking 180, or whatever the measurement is given for the arc measure, or the central angle. Both are equivalent. So this would be the arc measure going around the outside, central angle going around the inside, and we divide that by 360, the total measure of the circle. Once we do that, then we have the portion of the circle, and we multiply that by the area, and we can find pi r squared over 2 is the same thing as I wrote above. So if we were to say that the area of the whole circle were 20 inches squared, then the area of this half circle would be, obviously, half of that, which is 10 inches squared. Now, let's go over here to our formulas. Here we see that area times our portion of the circle. This is what I talked about earlier. Same deal with arc length. We take the portion of the circle, but instead of multiplying by the circumference, we're multiplying by area. When we're dealing with radians, we're going to divide by 2 pi because there's 2 pi radians in a full circle. And then we multiply by the area, which is pi r squared. Now, with radians, the one thing you should take into account is that when we multiply pi r squared times r theta over 2 pi, the pi's are going to cancel. So what ends up happening is our final equation is going to be theta times r squared over 2, and that's going to be our sector area. Sector area. And just to clarify it for this one, it would be theta pi r squared over 360. So that would be the full formula for that. But I like thinking of it this way because we're thinking the portion on the right, the area of the full circle on the left, and when you multiply those two, you get just the portion that you're looking for. Let's go ahead and apply it to number 13. We have this little slice of pie here, and it's only 60 degrees of the full 360 degrees in the circle. So first, we always need to find the portion of that circle. In this case, it is 1/6. So we're going to take that 1/6, and now we're going to multiply it by pi r squared of the entire circle. Well, we have pi, our r is going to be 10, and we're going to square it. Make sure to always do, and this is going to be our sector area. Make sure to always do the squaring first. We have 100 pi over 6, and honestly, I would leave it like this. And then we'll just make sure to include the units, inches squared. I think it wants nearest tenth, so actually I'm going to pull out my calculator. You can hear it getting locked and loaded here. So I'm going to do 100 times pi, and then divide that by 6. I just typed that right into my calculator, and I get 52 point nearest tenth, it says, so 4 inches squared. And that's going to be my little itty-bitty sector pizza area right here. Okay, let's go on to another example. Moving right along to number 14. Number 14, same deal. We're only looking for a portion of this circle, not the full thing. So we need to multiply the area of the full circle times the portion that 150 is of the complete circle. So we're going to take 150, divide by 360. Oops, 360. And that will tell us our portion, 150 divided by 360. Now, we could either write this as a decimal or a fraction. Wow, I just realized, I looked down and I saw that didn't resemble human writing. This is equivalent to 0.416 repeating. Okay, so we could do a couple things here. One, we could reduce this 15 over 36. I don't think that's necessary since we're only worrying about rounding. So I'm just going to leave it as stored in my calculator, and I'm going to multiply this by everything else. So 0.416 times my pi r squared. Okay, because remember the whole formula is this right here. And I already calculated my theta over 360. That was this portion right there, okay? Just so you are up to speed. I'll do it a little bit more thoroughly in the next one, just so you can see it all out. So now I'm going to be multiplying 0.416 times pi times 3 squared, which is 9. So I'm just going to type 9 times that stored number on my calculator times pi, and I will get my final result for the sector area, which is 11.8 meters squared for this one. And that's all there is to it. Once you understand what you're doing, I feel it's much easier to figure these problems out, okay? So make sure you guys take the time to understand what you're doing with this. And then, of course, part of the formulas you'll need to memorize, but I'm not a fan of just memorizing for the sake of memorizing, okay? So understand what you're doing, and then we'll apply it. So we already went ahead and we did a few examples getting carried away making a pizza. For degrees, let's go ahead and move on to radians. So here we have 15. 15 is 3 pi over 2 radians out of the whole. So we are going to use this formula over here. This one, okay, so theta times r squared, 3 pi over 2 is our theta, times r squared over 2. Or you could multiply that by 1/2. Since we already have a fraction, I'm going to say this is multiplied by 1/2. Okay, so just as a recap, the original formula is theta times pi r squared over 2 pi, but we just simply canceled the pi's out. So now we have theta times r squared times 1/2, which is the same thing as divide by 2. And that is what I'm going to input here. So instead of r squared, I'm going to put 4. I'll use blue. And then we're going to just solve from here. So we have 4 squared is 16. Always start with that. So we have 3 pi over 2 times 16 times 1/2. We're going to multiply 16 times 1/2 and get 8. 3 pi equals 3 pi over 2 times 8. I'm going to cancel that, and then we'll have 3 pi times 4, and that's going to be equal to 12 pi, which I would leave it like that, but this one wants it around to the tenths. So we're going to do 12 times pi here, and we get 37.7. And then the units are centimeters squared. Again, we're talking about area. In the first example, we were talking about the length, and we're talking about length, we're just talking about centimeters. If we're talking about area, we're talking about centimeters squared. Now it's asking us not to round, so let's go ahead and do this. So we have 240. We're going to have to simplify these fractions. So we have 240 over 360. I told you I would do an example that more thoroughly. So we have theta over 360 times pi r squared. So we have 240 times pi times 16 squared, like this. Okay, so this would be what the full formula would look like for the sector area. Now what we're going to do is we're going to simplify. So I'm going to cross off that. You can divide both 24 and 36 by 12, and you get 2 pi 16 squared over 3. So now I need to do 16 squared. I believe that's 256. So I have 2 pi times 256 over 3. I don't think 256 can be divided by 3. It cannot. So we're just going to multiply across, and that will be our final answer. So 256 times 2 gives us 512 pi over 3, and then we have feet squared. Let me move this over, actually. And that's our final answer. It doesn't want us to round, so it just wants it to reduce as much as possible, leave in terms of pi. Let's do the 315 one. 315 times pi times r squared over, sorry, r squared. I should just go ahead and put it in 14 squared. 14 squared over 360. This one's going to be a little tougher to reduce. We need to find common factors. I wonder if they're both divisible by 15. And 315 is, 360 should be also. And it is. Okay. So I reduce both these by 15. I get 21 times pi times 14 squared. And I guess I can go ahead and do 14 squared, which is 196. So I'm going to write 196 instead. Now, I believe I can reduce more, and I can. Both of these are divisible by 3. So really the number was not 15, it was 45. 45 goes into 315 and 360. That's the way you can figure that out. So I divide it by 15, and then I divide it by 3. So you can see I could have jumped ahead and just combined these to divide by 45. I'm just showing you an easier way to reduce these, okay? So you can always do it in segments like I did, but that would have been the quickest way. So I divide that by 3, I divide that by 3, pi times 196. I'm pretty positive 196 is divisible by 8. It is not, but it's probably divisible by 4. It is not. Definitely divisible by 2, so we'll divide that by 2. Wait, hold on, 196 is divisible by 4. Sorry, hold on. My calculator's having some conniptions. So we have 7 times pi times 49, because I divided by 4, and this was 2. Okay, so now I'm almost done. I just do 49 times 7 times pi. Well, I'm not going to multiply by pi. I'm going to leave it in terms of pi. So I get 343 pi over 2, and my units are inches squared. We're almost done here. We're going to do another one of these. I'm not a big fan of these ones personally. I always like visual, but you would just essentially draw the shape and then go from there. But I'll just do the ones that are visual. I'm going to do one of the pi ones. Let's go ahead and let's do, I guess we'll try both. All right. So we're going to go ahead and use our simplified formula for this. We're going to use the theta times r squared over 2. So theta times r squared over 2 for our area. So we're going to do pi r squared. Actually, I'm going to multiply that by 1/2 instead. So that's going to be my sector area. So 3 pi over 2 times r squared times 1/2. R squared is 14 squared. Okay, times 1/2. Now, anything I can cancel right away, I'm going to multiply 14 squared first. I get 196. 3 pi times 196, and then over 4. I multiply the two bases together, and I get 4. 196 is divisible by 4. It gives me 49. So I'm just going to cross off this, write 49. So now I just do 49 times 3 times pi. I get 147 pi centimeters squared. So you can see with radians it's a little bit easier. And we'll do one more, this one. 19 pi over 12 times pi, oops, nope, the pi is canceled, times r squared times 1/2. Okay, I want to multiply the bases first. I get 24. I forgot to write this guy in again. This is going to be 12 squared. And actually, no, I'm not going to do that first. So check this out. I'm going to write it like this. 19 times pi times 12 times 12. 12 squared is the same thing as 12 times 12. And then 12 times 2 in the bottom. I'm writing it out in expanded form so you can see this. Boom, boom, like that, so we don't have to worry about multiplication. I could have done something similar over here, but let's go ahead and continue. I'm going to cancel this. I get 6. That gets canceled. And now I just have 19 times 6 in the top. Makes it way easier, and I get 114 pi. And then what are the units? Feet squared. 114 pi feet squared. Ugh, barely got it. Okay, just go ahead and pause it if you need to copy that down. But that's it. That's all there is to it for sector area. It's really not that bad. Very similar to arc length. Hope you guys enjoyed this video. Make sure to check out some of my other videos on geometry, especially area. And I look forward to seeing you next time on Wes Explains Best. There, I got it that last time. Took me 2 tries, but I got it.